Okay, in this segment, once again in the probability slice, the probability of intersection or union word problems. Of course, most students don't like word problems, and so let's go through and read this one and see what we have. Now, Steve has a 52% chance of receiving an A grade in statistics, a 42% chance of receiving an A grade in geology, and a 33% chance of receiving A grades in both statistics and geology. Find the probability. Now, here comes the question then. So perk up here. Find the probability that he receives an A in statistics or, and here's our key word, or geology, or both. So as soon as we see this problem and we find that little word right there, or, we know that we are dealing with a situation that's best handled by the or formula. And so what let's do is to take a quick look at that formula and a few notes. Now, once again here, we're going to be looking at the OR formula, and this is used in a couple of different lessons. The probability that A or B occurs is the probability of A plus the probability of B minus the probability of A and B. And students sometimes ask, well, why should this be the case? Why would you do this? And my typical response again is, well, look, some guy figured this out 300 or 400 years ago. He got famous for it. We're not going to. So what we need to concentrate on is how to apply this formula, how to use this formula in many different cases. And there are a couple different versions of this problem. In this particular case, they're asking for the probability of A or B. So they're asking for this answer. What we're going to have to do then is simply plug in these three parts here, plug those in, and solve that out, and do the math, and we'll get the answer. There's another variation of this problem where sometimes they give you this and then something over here is unknown, so we'll have to be alert for that. That will come up at times as well. Let's go back and look at the problem they're giving us now. Now notice here, Steve has a chance of receiving an A grade in statistics. Okay, so that's kind of like our A part. The 42% chance of receiving an A in geology, that's kind of like our B part. And a 33% chance of receiving grades in both statistics and geology. So let's go back over here and interpret this a little bit more. So back to our notes. And we will see here that in this case, they want the chance of getting an A in both statistics and geology. And so, A represents statistics, B represents geology. And so what we're going to do then is go right across our formula. Once again, A represents the chance of getting an A in statistics, and they've told us here that Steve's chance of doing that is 52% chance. We will convert that into a decimal. And so what we will do here then is go 0.52. We're going to add that to B. Now remember B, that's his chance of getting an A in geology. So we go back here and see that the chance of that happening is 42%. A in geology, so 0.42 is going to go there. And then we have the probability of A and B. That's the chance of his getting both an A in statistics and geology. And they tell us that the chance of that happening is 33%, which we will convert to a decimal as 0.33. And so really all we have to do then is to do the math and get the answer for that. And for that, I get 0.61. Let's go over here and try that in ALEKS. And that is correct. Let's look at another variation of this problem. In this one, it says, suppose that 59% of all adults in a certain community are obese and that 46% suffer from diabetes. Now, if 63% of the adults in this community are obese or suffer from diabetes or both, What is the probability that, here comes the question now, what is the probability that a randomly chosen adult in this community is both obese and suffering from diabetes? Well, once again, if we take a look back at our formula for this, we will notice that we're going to use the same formula as before, but they're giving us this answer. They're giving us the probability of A or B. Let's look back at that and see that that's true. It says here, notice that in the second sentence, 63% of the adults in this community are obese or, right there it is, or suffer from diabetes or both. So the probability of A or B is given to us, and that is 0.63. And so right away what we can see here is that we have the answer. We have the answer, and we're missing part of the question. And so kind of like Jeopardy, and we know what the answer is, but we have to form our response as a question. And so this is the flag that we're going to have to do algebra. We're going to have to do an algebra problem here, because it is the probability of A and B that we don't know. Because it says, once again, what is the probability that a randomly chosen adult in the community is both obese and suffering from diabetes? It's the A and B, which we don't have. And so what we're going to do here is once again immediately call that X. Okay, and so in algebra, anything we don't know, we always call that X, and then we proceed to solve for that. So let's see what else we have here. Now we notice here that 59% are obese. That's our A part. And so what we'll do then is code that over here. So 59% are obese. And we also are given the fact here that we have 46% suffering from diabetes. That is our B part. And so we need to get that coded in. And so then we're going to have our equation set up. 0.63 plus, or is equal to 0.59 plus 0.46 minus x. And so we're going to need to proceed to solve for that in a series of steps, just like we did back in the algebra types of problems. Now we'll notice here that the 0.59 plus the 0.46 adds up to 1.05, so we can make that simplification and write a step. 0.63 equals 1.05 minus x. Now, we could do this next step several ways, but one of my favorite ways is to get the x on the left-hand side. Notice that it is negative. If we change sides, we will change signs, and immediately that x will turn positive. The 1.05 is already on the right-hand side, but if I move the 0.63 across to be with that, we're going to have to change signs. So we'll have minus 0.63. What we'll need to do now is just grab our calculator and do that math. And so we will have 1.05. We will subtract 0.63 from that. Our answer is 0.42, which should be the answer that is going to make Alex happy. That is going to be the probability that the randomly chosen adult is both obese and suffering from diabetes.